Okay, I think we're at the point now where we should start talking about lists in Java. We've talked about inheritance, we've talked about composition pretty well. Hopefully we have a good, clear view of what those are. This is just to give you a full, concrete, solid example of a good way to use all these techniques we've used so far. And lists inside of Java is a pretty good way. I stole these slides from the internet. I wish they put the link in there because I don't remember where they are now. But hey, as long as you say you took them from someone else and you try to put a link up, it's not academic dishonesty. Yeah, if you, in other words, if in your code you submit your code and you say I copied from here, I can't get you expelled from the university because you cited your source. I'll just put a 0 for your grade. It's same thing, same principle. So, all right. I know it's kind of a weird line, but that's how it is. All right, so a list. Before we can talk about lists, we have to talk about collections inside of Java. When I'm talking about Java, I'm talking about the Java standard library. So a collection is a group of all objects called elements. Hopefully that is intuitive. A set is an unordered collection with no duplicates. For any of y'all that have done sets in math, that hopefully is intuitive. So you can talk about sorted set, which would actually sort it with no duplicates. A list is an unordered collection where duplicates are allowed. And a map is a collection that maps keys to values. Which is something completely different. Note that collection and map are two separate things. We're going to talk about collection today, not about maps. So a collection, you just simply import it, java.util.collection. One note, caveat, just to make sure we're clear, there is collection and then there is collections. Collections is basically a utility for sorting, doing a binary search, which is a more efficient search. See, copying, shuffling things, reversing, min, max, etc. There's actually a whole slew of functions in there for operating on collections. But we're talking about the collection, not plural, even though sometimes you'll see the S pop up in these slides. So the collection is actually an interface. And I will go show you that right now by going Java collection. We will go straight to the collection interface. So interface collection on generic E. I need to talk about generics in a bit. But you can add something. So it contains the specified element. You can add everything from a collection into the collection. You can clear it to remove it. You can ask if it contains something. If it contains everything in another collection, if it's equal to. Empty, remove an object, remove everything in this collection, retain all, which is, retain only the elements in the collection that are contained in the specified collection. What would that be in set if you're using sets? Have you done in math where you're talking about sets and you do unions and intersections? Not yet? Not quite? I mean, you can say no. No?
Which
Okay.
math is that in?
Huh?
Which math is
It's
that
in discrete.
It's in discrete where you start talking about set?
We've done unions and intersections, but I'm not sure what you mean by sets.
Well, if you have two sets, one set's 1, 2, 3. The other set is
Yes.
3, 4, 5. The intersection is 3.
Yes, we have.
Okay, right. And then union of 1, 2, 3 and then union of 3, 4, 5 would be 1, 2, 3, 4, 5.
It'd be everything.
Hmm?
It'd be everything.
Right, be it all. So retain all, what would that be? Retains only the items in this collection that are contained in the specified collection.
It retains what's in the collection.
Mm-hmm. So it's saying it has to be in both collections for it to be retained, which is like intersect.
Oh, okay.
Yeah. So it's another way of saying intersect. Where add all is union, because you're adding everything into it. And then there's a way to convert it to an array. All right, one thing I want to show you. Let's see, we have interface collection. it is an iterable. We'll talk about that in a bit. But notice that list inherits from collection. So if we go to list, interface list, super interfaces, aka parents, are collection and iterable. So a list is a collection. All right. So each kind of collection has one or more implementations, so you can create new collections, right? Some collection methods are optional. This is very confusing because in Java you can't really define a function to be optionally implemented, but since collection is part of the Java standard library, they decide to make a couple of them optional. It's not that big of a deal. All right, wow. Okay, you know what? Let's jump over. Let's start doing some code. New Java class. Oh, wait a minute. Hold on a second. How much time do we have? Okay, we'll just do standard collections. All right, let's see. Collection fun. Yup. Public static void main string args. All right, so you can have a collection C equals. Now, am I allowed to just put in new collection? No. Why? Reasons. So collection's an interface. You can't actually instantiate a collection. List can't be done because list is an interface as well. But I can make it an array list. And we'll go ahead and import that. There we go. So now we have an array list. Let me just go ahead and for int I equals 0, I is less than 100, I plus plus. We'll do c.add I. So it'll be a collection of the integers from 0 to 99. Okay. And if I create another collection, I'll call it C2, also an array list. And I add the numbers. We'll go from 50 to 150. So that'll be 50 to 149. So we have two different collections. Now,
So a collection is an unspecified length array list?
Great question. A collection is simply a class that implements the methods listed previously. In other words, with it, you have to be able to add an element, add all elements from a collection, clear it, ask if it contains an object, if it contains all the elements in a collection, is it equal to an option, is it empty, be able to create an iterator, remove all, retain all, size, and to array. All a collection has to do is implement that interface. That is all. It does not necessarily have to be an array. It can be a completely different data structure. It could be a linked list, binary tree. You could try and make it a heap. That would be interesting. B tree, a trie, hash table. It could be all sorts of things. But all it has to do is implement this interface. A very key point here is I am breaking apart the use of the class from the implementation of the class. Because the use of collection is defined here. What it actually is defined on this side. That's very important because I'm breaking that apart. Why would that be important? Ooh. I might have touched base on it a bit. We'll see if we can get to it. But I just want to show you we have collection. Now there's two different ways to iterate. I will show two different ways to iterate over a collection. Or actually, I think there's only one. There's only one way to iterate over a collection. Never mind. Notice inside this collection, there is no .get. So it does not assume that you have an array. So the question is, how do you actually get each element? Well, you have to use something called an iterator. So iterator I equals, we'll call c.iterator. I will implement this, import that, and put a comment. This is how you iterate over a collection.
So that just runs through it?
Yeah, it's going to run through it. So while I.hasNext. So an iterator I is a class that's going to point to the first element of your collection. When you call the .iterator, .hasNext says, is there anything left in this iteration of the collection? And then to actually get it, you would have to do system.out.print I.next. And I'll go ahead and give it a comma space so we can get it spaced out. And then afterwards, I'll give it a new line. So what this is doing, first, end, query the collection for an iterator. While there still are items to visit, grab the next item and print. Okay? So if I were to run this, zero, 1, 2, 3, all the way up to 159. Ooh, wow, that was a lot. Oh, because I added it to C up here when I meant C2. So let me try that again. There we go. 0 all the way up to 99. So what's different about this than what you're used to? What are you used to so far? The for loop? For int I? So what's different about this one?
What's different about the way we're using this for loop?
What's different about using the iterator versus the for loop?
Nothing.
There's not three conditions. Only one. Like in a for loop, you have
Okay, yeah.
two things.
What I'm trying to ask is, the way you're used to doing it is for int I equals 0, I is less than size I plus plus, right?
Yeah.
Do we have, how is that different than this while loop that we have? Besides the fact that this one says while, the other one says for.
Well, this one you're not setting values.
You're not saying,
You're not setting values. You're just printing them, right?
you're just printing them, right? But I could do the same thing with the for loop, right? .get on I.
I guess I don't know what you're asking, I guess.
Just trying to see if we could. Well, is there an index with this one? No, there's no index. Your for loop always had an index, right? Whatever I was the index into your array. Here we're just getting the next item and going forward. You see how it's accomplishing the same task, but differently. Does that make sense? Okay.
So it's accomplishing the same task. When in this scenario we would want to use that over for loop.
Over a for loop. That is a great question.
Because you're basically saying we can use them the same.
All right.
But here we have to have a collection versus
Okay.
not necessarily have a collection.
Hang on. Let me think here. Oh wait, what'd you say? You have
You have to have a collection, but to run it through in a for loop, you don't have to have a collection.
Well, you can't do the for loop on a collection, but you can do it on a list. I'm trying to think of the best way to answer your question, Alex, without going into data structures.
So that's what it has to do.
What?
It has to do with data structures.
Yes, because some data structures, if you're just using an array and you're iterating through it, you know, that's with a for loop, that's fine. But if you use another data structure, that doesn't make much sense.
So you're talking about like for like really, really big things?
Yeah.
That's where it's.
That's where it starts to. And let me see if I can come up.
Does has next return something if the next value is null?
Yeah, it returns false.
So it wouldn't continue if the next value was null.
Hold on.
Because if you were in an array list and you had something in position 0 and position 8, it would only do the 0.
Okay, hold on. If you had an array list, oh no. I see what you're asking now. Sorry, I misunderstood you. If your array list contained 8 nulls, has next would return true on 0 because you have null next. You can that what you said is that member value is null. I'm trying to come up with an easy example. So let's, we haven't talked about linked lists, but let's create a list of integers, or int. And we'll call it I equals new linked list. All right, so we have a linked list. Let's see if I can whip this out real quick. Oh, we can't have, has to be a capital I integer. And I is already taken, so we'll call it the I list. All right, so for int I equals 0, I is less than, oh, what should we do? No, we need a big number.
7,000.
Hopefully that's big enough. ilist dot add that integer. And let's say we want to take the sum. I can't use I here, so I need to come up and call this iter. Whoa, that was a caps lock. Let's try that again. All right, we add it all up, and let's say later on we want to do something to each item. Just to keep things simple, let's do it with a for loop. I equals 0, I is less than ilist.size, I plus plus, and we'll try and get a sum. So long sum equals 0, sum plus equals ilist.get of I. All right, and then we'll go system.out.println sum. All right, let's see if this does what I want it to. Oh, it is. Notice the program has not ended. It's still running.
Oh, no.
It's taking a long, long time. That's because with the linked list, it takes a long time to do get.get. That's a very expensive operation. I haven't talked to why that is, but I'm just telling you it is for now. So let me stop. What if instead of this for loop, we did, we'll go and do the ilist version, oh, not that one, I'm sorry, the iterator version. We don't want to uncomment long. And instead of C, we'll do ilist, and then we'll have sum plus equals iter.next. Too long and type object, so we need to cast it to an integer first. There we go. Now let's run it now. Wow, that was
I
fast.
will keep that in mind for my next class. For data structures.
All right.
Wow, that's way faster.
Way faster. So, by breaking it apart, in this case, the iterator for a linked list was optimized for that data structure to iterate through it, while the iterator, while doing the .get, it's not doing any optimization, so to speak, of how it goes through the data structure. The thing about a linked list is you can't jump to a specific location. You have to start from the beginning, iterate to it, and then you can finally grab it. But you're just iterating, you just follow it along the list and you're done. Okay. Now, all right, well that was any questions about iterator? That was, I guess, a pretty solid reason for why we use iterators, is performance. Any other questions? I don't know if I'm just doing a good job explaining it, or everyone is just like, yeah, let's move on. Tyler? Doing it? All right. Just need some feedback. Okay, so that's why we use iterators. We jump back to these slides, make sure I'm on top. So you can get the size of a collection, you can ask if it's empty, you can ask if it contains something, and then you can add an object as well. So literally you can, after the sum, I'll do system.out.println, not sum, but ilist.contains, what do we want to try, 999. So that should print out true, and this one should print out false. So let me go ahead and make that a little more clear. So does ilist contain 999 plus, and then we'll do does ilist contain negative 999 question mark plus. Let's run it. There we go. True, false. So it just provides that capability for you. The reason I'm kind of trying to be hesitant of the data structures, and I'm trying to teach you how they're used and why they're used the way they are. That way when you go to data structures, it'll make sense, why we're learning the details. Also for, do we have any minors in here? Are you a minor? You're major? Awesome, major. Oh, great, we're all majors. Okay, good. So you'll learn in data structures. Iterator, that returns an iterator that can iterate through the collection. All right, the interface, iterator is an interface. You just need two things. Does it have another object, another element? We'll get the next one and advance the iterator afterwards. That's all it does. I showed you how it was done just now. Oh, so here's the code again. I just typed it up there, but you can look at it again if you want to. Notice it just creates an iterator by calling .iterator. While it has an item to iterate to, print it out. That's all. Oh yeah, this is a good point. The code is polymorphic. What does that mean?
It has more than one white.
Wrong one, Tyler.
Whew, all right. That's a different word. Good try. What can I pass to this function?
Any collection.
A what?
Any collection.
Any collection. What's another class that I can pass besides collection?
List.
List. Or array list. Or linked list. Or any other type of list. That's what it means by polymorphic. You can ask if it contains all. You can add everything from a collection. You can remove it, retain, clear. Right. Return true if the message was modified. Great. Most methods contains all. Okay. Don't worry about the singleton class. Lastly, you can always convert a collection to an array by calling .toArray. That'll cast it to an object array, which may not be what you always want. So you may want to be able to pass it. So for example, you do toArray, or if you wanted to return as a string, you do c.toArray new string, just giving it some string, and it'll give you back a newly constructed string object. All right. I think before I continue, I'm going to stop here so you'll have time to work on your lab and your project. How's the project coming?
Good.
Good so far? Y'all doing great? All right. I like that. Any questions about the midterm? Might have popped up while I was presenting? Nothing? All right. Well, you have just over an hour. I suggest getting your lab done because Lab 5 will be assigned next time.